All right, so yesterday we stopped with number 5, so let's go back and look at it. I think you all had enough time to look at it to see if you could figure it out. So it says a graduated cylinder is placed on an electric balance, okay, and the scale reads 78.32 grams. 10 milliliters of glycerin are added, and then the scale reads 91.78 grams. What is the density of glycerin? So again, the first question you always need to ask yourself is, what am I solving for? What's the purpose of this? So what are you actually trying to find? The density of glycerin, okay? Do we have a formula for density? What is it? Mass over volume. My next question, is there anything in the data part of this question that I can use right now as is? Very good. And where am I plugging it in? On the bottom for volume. So I've got 10.0 milliliters. Now here's the next part. I've got to have a mass, but how many masses are given in the data? 2 of them. So I'm going to ask a really silly question. Which one do I choose? The 78.32 or the 91? Neither, right? It's a trick question. What this is kind of like water displacement, but it's really mass displacement. I want to stop for a second and actually talk about the physical reasoning for doing this. You know what a graduated cylinder looks like. So why do we need to know the mass of the graduated cylinder before we can determine the mass of the glycerin? So can you just pour that glycerin on the balance to determine its mass? No, it doesn't make sense. It'll just go everywhere. That won't hold it in. So what's the purpose of needing to know the mass of the empty graduated cylinder? To find the difference, right? So when you find what the mass is with the glycerin in it, to be able to determine what the glycerin actually makes up, you have to subtract the mass of that graduated cylinder. What was the mass when you do 91.78 minus 78.32? 13 point what? 46 grams. Fantastic. Okay. Now, when we do this mass, and I actually sat down during second period, what is going on? Duh, that was stupid. And I downloaded my handy dandy fancy calculator. Ooh. You didn't ooh with me. Ooh. Alright. So this is a graphing calculator, as you can tell, but it makes life a lot easier whenever you can kind of see it. You can, absolutely. And I agree with you. That was a really dumb move by this part, but it's just kind of a way to word the question for you. Okay. Now, and let me actually, Alex, let me throw this curveball at you. Let's say we use a crucible, that little porcelain-looking thing, and I need to know the mass of the compound after we heat it. You with me? Those are more of a situations of why you would need the mass of the empty one, because you can't take that stuff and dump it out. So you need the empty one versus when it's really hot to then find the measurement. So this one, you're right, is a lot easier, but with a crucible, it wouldn't really work that way. Okay. All right. So we need to do the math here. So it is 13.46 divided by 10.0, and there is my answer. Okay. How many of you wrote down that whole value? Okay, if you did, that's fine. Significant figures are something we'll talk about later, but the correct answer in correct significant figures is 1.35. Again, it's not a big deal. It's one of those things that I like to challenge you guys with up front, so you're having to really pay attention when you're writing an answer. You're not just looking at the calculator and not thinking. You actually are contemplating what's the appropriate answer. Now, if you left it as that, I don't know what that is, okay? Is that how much money you have in your bank account? Like, what is that amount of money? What is this? You're right. Grams per milliliters. Okay? So, that's what, guys, I promise we'll talk about sig figs later. I know y'all are so overwhelmed with them. All right, so let's look at the next one, number 6. Number 6 actually has 2 parts. It tells you have a 3 centimeter by 4.5 centimeter by 6.7 centimeter brick, and it has a mass of 985 grams. And question A is, what is its density? Question B is, what material is it most likely made from? So I like this question because it asks you specifically for its density, but question B is important. how in the world are you supposed to know what that brick is made up of? Okay, Ralston. Very good. Look up in the top right-hand corner. What is the label of that chart of all that stuff? What are those numbers? They're the densities, right? So what we can do is every substance. Yes, ma'am. So every substance has a specific density and it never changes. If you have a drop of water or a pan of water, is the density of water always 1? Yes. So it doesn't matter how much you have of this stuff. So whatever the density is, it will always be that no matter how much you have present. So let's start with the first question. We know we're finding the density. So density is equal to mass divided by volume. Now, the next question is there anything in the data that was given that you can use exactly as it is written currently? Which one? Very good. The 985 grams, okay? That is good news for us. We can actually use that. Well, the next part comes in and we have an issue. They gave us all these 3 things, but we don't have a volume. But how can you find the volume? Okay? So I don't know what these orders are, but length times width times height. Now, and if you look up there in the top right-hand corner, I'm going to scroll up so you can actually see it. Underneath the substances with all the densities in them, over here on the right-hand side, where it says volume equations, it explicitly says a block, which is a brick. And it tells you exactly how to calculate the volume. We're going to need those other 2 in just a minute. So we'll scroll back over so we got it right here. Now, so what is your length times your width times your height? Okay, now, I'm going to do 3 times 4.5. Why did I pull up this calculator? I've been in a habit. I need to take it off the pin list. All right, so 90.45. So 90.45. Let me unpin it so it goes away so I don't use it anymore. All right, so let's close that out. Let's unpin. Thank you. Yes, that was actually what I was fixing to get to. I was pulling up my calculator first. So a unit on this thing. What is a centimeter times a centimeter times a centimeter? Very good. So we've got cubic centimeters or centimeters cubed. So now we need to figure out what our density is. So 985 divided by 90.45, and that's the answer that you get. How many of you just say 10? How many of you say 11? 10.8? 10.9? 10.88? 10.89? Okay. It is 10.9. I promise, don't stress yourself out over it. I guarantee when I actually teach this, you're going to look back and say, God, I was dumb. Okay. Again, the unit is grams per cubic centimeter. Wow. Cubic centimeter. All right. So, the next question that was proposed is, what is this made up of? So if we scroll back up, what substance has a density close to 10.9? Lead. It's going to be the closest. Now, due to some rounding errors, that is why we're not closer to 11, because we are using significant figures, but it is close enough. Okay, I would like for it to be a lot closer, but it is what it is. So for A is 10.9. The answer for B is lead. All right, so let's move on to 7. Yeah. Sink like a rock, wouldn't it? How many times more dense is lead than water? 11 times more dense. Okay? It would sink very fast. So you guys know lead, it sinks. Okay? So number 8. Nope, actually 7. A cylinder has a mass of 528.6 grams, a length of 14.2 grams, and a diameter of 2.3 centimeters. What is the cylinder most likely made of? And I know this is a weird question. What does the answer have to be? Is it a number? No, it's a substance, right? Well, the only way we can determine that substance is by calculating the what? The density. So we have to get a number, but it's not going to be the answer. Okay? So we do have to calculate the density to determine what the substance is. So the density is mass divided by volume. So my question to you is there any number in the data that can be plugged in right now? Very good. So 528.6 grams. Everybody cool with that? This next part is going to be the weird one. We need a volume, but they give you a length and a diameter. Okay? If you go up there underneath that substance, there is a formula for the volume of a what object? It says cylinder, plain as day, right there in the question, so you know it's a cylinder. Let me ask you something. What if they use a term like a rod, or a wire, or a pipe? Are those all cylinders? Okay, just making sure we're on the same page there. You're going to see wire in a little bit, so I want to go ahead and throw it at you. So the volume of a cylinder is pi r squared times the height, right? Now, pi is easy. We know what it is. 3.14. You know what, as a science teacher, it has always driven me nuts that pi doesn't have a unit. I don't know why. I just hate it. Okay? Now, r. What does r stand for? Radius. Now, what do they give you in the problem? The diameter. Well, what's the radius? It's half the diameter, which is what? 1.15 centimeters, and I must square that number. Now, a lot of people don't understand this next part, and I don't know how people just can't understand this. Very simple. It says the length. Is the length the same thing as the height? Yes. Where is this? This ruler is how many inches long? It is how many inches tall? Magic. Okay? Length and height are the same thing, just different directions. So when we come over here, and what is that number? 14.2 centimeters. Now, the first thing I'm going to talk about, I could care less about the number. Numbers are arbitrary. They can always change. Units always must be true. What is your unit based on this setup? Okay. We know, bottom line, it's got to be centimeters cubed because that's the volume unit. But how would we know that? What do you do to exponents of variables when you multiply them? So, we have centimeters squared times centimeters. So what is centimeters squared times centimeters? Very good. Centimeters cubed. Okay? So you add those exponents. Now, when you plug in these numbers, what was the value that you got? Let's try that again. So, turn it on, let me clear it all out so this will be easier to see. 3.14. You can use pi. Pi is perfectly fine. I'm just typing in 3.14 times, because I don't even know where pi is on this thing. Okay, I got you. I see it now. In all of my years in chemistry, I've never used pi. We celebrate Mole Day. We don't celebrate Pi Day. All right, so write down 51.3. The volume is 51.3. Oh, thank you. Very good. That is incorrect. Thank you for catching that. 3.14 times 1.15. It would be so much faster if I just stand over here and do it like this. Squared times 14.2. So, check. It is 59.0. I know, just accept it for the life that it is. 59.0. That is the volume, yes ma'am. And that's cubic centimeters. Okay? And then, move this over here, and I promise I'll get out of your way. So clear, we need 528.6 divided by 59. It's going to give us that number. 8.96. There you go. Some of you are starting to click for you. 8.96 3 sig figs. All right, so I'm going to give you guys a chance to do number 8, but before you do it, let me explain two things. Number one, the second word in that question is, it says a ball. What is another word to say a ball? A sphere. Keep that in mind. Number two, the two questions are, will the ball float or sink in water, or the ball float and sink in salt water? Now, what is the quality that we compare things to determine if we know it will float or sink? It's density. You have to compare their densities. If it floats, what is its density compared to the thing it's sitting in? If it's less than that density, it will float. Okay? If it's more than that density, what will it do? It will sink. Now, we should know this. It says in water. What is the density of water? 1 gram per milliliter. Now, question B says, will it float or sink in salt water? In this hint, you can't see it up here, but what does it say? C number 2. You should have the density of salt water in question number 2. So when you calculate the density of this sphere, compare A and B. It will either float or it will sink. Go ahead and see if you can do that one. The pi button? Yeah, you got to find the density first, and then compare the densities to the two the two liquids. Now, I'm not going to go through all of the math on this. The one thing that I do want to talk about, we've already talked about, we know we need density is 753 grams, but the volume is the question. What's that formula for the volume of a sphere? Okay. Now, I just want to say this out loud to make sure that we're all good in terms of calculation. Does order of operations matter here? What's the first thing you need to do? Cube it first, okay? Cube it and then multiply by pi, then by 4, and then divide by 3, okay? So as far as making sure you have this right, what was the volume? And again, I didn't plug it in. What was it? I don't care about the decimals or anything, sig figs. Just give me a number. 743.2. And if you round it differently, that's fine. But it was as long as you're in that range, 743 something-ish, okay? So when you found the density came out to be 1.01. Right? 1.01. Now, question B of this was really easy. Will it float or sink in salt water? That wasn't a yes or no. That was a either or. It'll float. Why will it float? What's the density of salt water? 1.183. Well, 1.01 is less than that, so it will float. The harder question for you guys is, what is 1 compared to 1.01? You're right. That's really close. Dorian, what'd you say? It'll be in the middle. It doesn't float. It doesn't sink. It just kind of sits there. Okay, so it's actually a trick question. Personally, I don't like that trick question, but it is what it is. They were trying to find a number that was in between that will float and that would maybe sink in water, but not float in salt water. It will not sit on top. I will tell you that. It will be submerged more than anything. Okay. All right, so the last two I'm going to help you with, and the back I'm going to let you kind of go on your own. So number 9, it says, how much would a 5.2 milliliter chunk of styrofoam weigh? And B says, how much would the same size chunk of osmium weigh? All right, well, here's the deal. What are we solving for in both of these things? Mass. We're solving for mass. Now, using your density triangle, what is the equation for mass? Density times volume, okay? Now, so, what do we know is the same about both of these objects? The volume is the same for both, right? And it's 15.2 milliliters. Now, the first one I'm going to do, this is going to be for the styro, and this is going to be for the osmium, okay? So I know that it is 15.2. So my question to you guys is, they never gave us a density. So how are you supposed to know? Look at that chart at the top. Okay, what is the density of styrofoam? Before we even ask that, let's just think analytically. In comparison comparison to a value we do know. We do know the density of water is what? Would you expect styrofoam to be more or less than 1? Why would you expect it to be less than 1? Styrofoam floats. Is it less than 1? It's like 0.1 something, isn't it? 145 gram per milliliter. Now, osmium is ridiculous. It's like 22 point something, isn't it? 22.6. In fact, I will tell you this little factoid. Osmium is the most dense element on the entire periodic table. There is nothing more dense. It is the densest object or element on the periodic table. Okay? So, when you do the math, it should come out fairly simple. Let's do the first one together. We have 0.14. If I turn it on. 0.145 times 15.2, and then 22.6 times times 15.2. So there's both of our answers. Okay. What would you round the first one to? 0. 2.20. Now, what's your unit? What were you solving for? Grams. So 2.20 grams. Now, here's the funky one. What would you round the last one to? 344. Now, 344 what? Grams. Good deal. 344 grams. So, the crazy part about that is, it's the exact same size cube. Exact same size cube. But notice what we have as far as the amount that they weigh. Is it significantly different? Yes, significantly different. And it's all based on the density. Okay? You have more mass per volume in that object. Now, everybody good on this? Okay. If you guys will flip over, we're going to skip 10. I'm going to let you guys do 10 on your own. But there's something I need to tell you about 11. And it's a calculator issue. Some of you have done this before. Some of you have never done this in your calculator. And I need to explain how you actually perform this operation in your calculator. Because if you don't know, it's going to be a problem for you in the future. Because we're going to be using this function a lot. Especially when we get to something called Avogadro's number. Yes, not avocado, not that fruit that you eat. Avogadro. It's a G. So, number 11. A piece of gold wire has a diameter of 0.175 centimeters. How much will precisely 1.00 times 10 to the 5th centimeters, about 2/3 of a mile, of the wire weigh? Now it gives you a little hint. What does it tell you in the hint? Wire is a tiny cylinder. So we know about what we're going to have to do. Now, the most important question. What are we solving for specifically? What's the question in the question? The mass. We got to solve for the mass. According to the density triangle, mass is equal to what? Okay, density times volume. So here's the deal. My first question is, which one of these values is the easiest one to find? The easiest. Why the density? It's on the chart. What's your substance? God, Grayson. It is gold. What is the density of gold? 19 point what? 19.3 grams per milliliter. Okay. Now, the next one, it's easy, but you got to do a little bit of calculating. Okay. Now, you guys have the space to work with this. I'm going to change page. I'm going to come off of this, so I'm going to need your help so I can write it down a little bit bigger. It tells us it's a cylinder, so we know the volume of a cylinder, a CLY cylinder, is pi r squared times h. Okay. Well, the easy part is 3.14. Now, the r is a little aggravating because they gave you the what? Diameter. What's half of 0.175? Okay? And that's centimeters, and we have to square this thing. Same concept as earlier. It tells you how long it is, but what is length? Same as height. And this is where the trouble begins. Just out of curiosity, again, this is not, I just want to know, how many of you ever seen that form written? What is that? What is the name of that type of number? What form is it written in? Perfect. Scientific notation. Okay. Just break your pencil. So what this is, by the way, this is centimeters. Instead of me having to write 100,000 centimeters, you can write it in that form. It means the exact same thing. Now, I know what you're saying. Isn't it just as easy to write 100,000? It is, but guess what happens when we have numbers like Avogadro's number, which is 6.02 times 10 to the 23rd. That means there are 21 zeros to the right of that 2. I'm not writing that. Okay? So this is why we have to have these things. Now, this is a really big number, right? Okay? Electrons are 9 point something, I can't remember those two numbers, times 10 to the negative 34th. That means there are 33 zeros to the left of that 9. I'm not writing that number. So do you see how important these can be? When you got really big or really, really small numbers, it is important to be able to do it. So the problem that I find students have is when we have to deal with these numbers is how do you use it in a calculator? You can plug in 100,000. That's easy. But when I ask you to do Avogadro's number, you can't plug in those 21 zeros in your calculator. It wouldn't work. So how do we do this? So here's what we're going to do. We're going to do the simple part first. Let's go ahead. Actually, I'm going to pull this up. I'm going to show you how to plug that number in, and then we'll calculate it. Now, the problem with this is that everyone's calculator is a little bit different. And I'm just going to have to walk around and kind of help you figure it out if your calculator is different. If you have a Casio, or Jackson, hold yours up so everyone can see it behind you. Just hold up. If you have that one, hold yours up, Amari. Or if you've got that one, hold them up again, both of you. Hold it up again. If you've got either one of those, yours is going to be a little different from what I'm fixing to show you. Okay, if you've got one that looks like this, or the Texas Instrument 30XA, then you're good. Okay, Texas Instruments, the TIs are a lot easier than most of them. So here's what you got to do. I need to put 1.00 times 10 to the 5th in. So I'm going to do 1.00. So start right there. Okay, that's the easy part. Here's the button you're looking for. If you will look at the button right above, actually I'm going to come off of this so I can write on top of it. If you will look at the button right above the number 7, so it's right here. Again, this is on the TIs. If you have the Casio, the blue one, it's not going to look this way. It's going to be different. You should see an option for 2 capital letter E's. It's either that button or it's a colored function of it. If it's the smaller colored function, how do you get to it? You hit the second, okay? Or alpha or second, whatever color matches, okay? So here's what I need to do. This is what's going to happen. On mine, I need to hit second, and then I'm going to hit that button. And notice what popped up in there, okay? That E. So here's what this E, this capital E in your calculator stands for. That is what it represents. So I've already taken care of the times 10 to the, correct? So what's the next thing that has to go in? The 5. That's how it should look. Now again, if you're having issues putting it in, I'm going to be glad to come around and help you guys out. So what I want to do now is I want to calculate it, and I want to see if you can get your volume to match mine based on what it is. Yes, sir. That's a good question. No, you can't, because it's not the same thing. You will be off by a factor of 10. Okay? You have to do it this way. All right. So I'm going to multiply times 3.14 times 0.0875, and that value is squared. And that right there should be the volume that you calculate. And I'm going to walk around and make sure that you get it. Oh, wow, this has been recording the whole time. My bad. All right, so what we now need to do is I'm going to leave this number in here as it is. If you want to write it down as 2404, that's fine. But what do we now do with the volume to find the mass? Multiply it by what? Times 19.3, and it equals that right there. So you should get 46,398.40652. Very good, Cody. Say it again. Very good. 46,400 what? No, what'd you solve for? Just grams. Okay, 46,400 grams. Okay, 46,400 grams. Okay. I'm just throwing this out there as a hypothetical. What if all of a sudden you have the exact same question, but someone said that wire was made of Cu? Now, what is Cu? Copper. Hypothetically, let's just think. Do you think the mass of the wire would go up or would go down? It would go down because, again, same wire, what's the difference? Copper is less dense than gold, so the mass would have to drop. Okay? Any questions? All right, so you guys, the time we have remaining, I want you to try to do as many problems as you can on the back. Go back to number 10 and then go to 12. And now, don't skip to it. We'll wait. But and never mind, I'm not even going to say it because people will go ahead and try to do it. So go ahead and try to do all of them, starting with 10. And I'll walk around and kind of help answer questions.